All right, so you have the software installed, right? So if you look at the software, this is your interface. This is the interface of your software. All right, so you look at, you have a measure workflow there that you have to follow in order for you to carry out acid simulation. So the first part here is our CSA. Once you put your mouse on it, once you put your mouse on it, you're going to see it defined down here. So when I put my mouse there, the CSA is defined down here as Candidate Selection Advisor. You see it defined down here. You have Candidate Selection Advisor is used to check the reasonableness of using metrics as dicing to treat a proposed well. So you want to be sure that whatever you have as your reservoir is suitable for acid stimulation. If it's not suitable for acid stimulation, they'll definitely tell you that it is not suitable for acid stimulation. So the first thing first is to verify if your reservoir is suitable for acid stimulation. So we are going to click on it. Once you click on it, it opens there. The first thing there is the introduction. They said we have to get started. Your well type, we are going to take our oil. You are going to choose the well type. The formation type could either be sandstone or carbonate. Is a pressure transient analysis available? Yes or no? Pressure transient analysis is widely used in the oil industry to determine the skin factor. That's the most valuable method of obtaining the skin factor, which we did a little bit of it. I think it was around week 4 or week 5 when we did well test analysis using Excel. And I showed how you could use either the drawdown test or the build up test in order to determine the skin factor of that particular reservoir. So if a pressure transient analysis is available, then if you say yes, then you must have calculated the skin factor from that pressure transient analysis. So you should be able to give the value of the skin factor. It could be, let's say, it could be for oil, definitely it will hardly be more than 7, 8 like that. So we could say 6 if you have the pressure transient analysis. If you don't have it and you take no, then probably you will need to do some calculation. You have to calculate. So let's assume that we don't have it, we take no. If we go forward, they will now ask you what is the geometry of the well. Is it a horizontal well or a vertical well? Then they will now ask you what is your current flow rate. What is the current flow rate? I may just say 200, 200 stock tank barrel per day. What is your reservoir pressure? Let's just leave it like that. What's your bottom hole flowing pressure? Let's just say around 900. What is the viscosity? What's the viscosity of the oil? Let's just say 2 centipoise. What is our net P? What's the net P of the reservoir? Let's just say 45 feet. And what is the reservoir permeability? Let's just say 25 milligauss. Once you input all of that, the system will automatically calculate the skin factor for you, which is about 4. Will automatically calculate the skin factor, which is about 4. Generally, if we are having a very high skin, then this flow rate may also reduce. If I put a flow rate of, let's say, 150, you realize that as the flow rate is reducing, the skin factor is increasing. The skin factor is increasing. So we have this. So this is our flow rate, but we have what we call theoretical flow rate. That means the flow rate that would have been at the surface boundary if there was no skin. The surface boundary is what that slight interval between the reservoir and the wellbore. At that interface where you have the reservoir and the wellbore, that's your surface. So that's what they call the theoretical flow rate. If there was no skin, this would have been your flow rate. But this is a flow rate because of this skin effect. That simply tells us that there is a drop of 47.1% of the flow rate. There's a drop of the flow rate due to the presence of the skin. So this is how you can obtain the skin if there is no pressure transfer analysis. The system can just do a rough calculation using all of these. All of this can be obtained using our general Darcy's equation. You can also apply that to calculate this skin. So if I go next, okay, they now ask the question. There are several possible problems other than damage which could cause poor well performance. Among these are, we have perforations, we have partial penetration, gravel packing, tubulars, low reservoir pressure, requiring gas lift, we have chokes and artificial lift malfunctioning. So these are other things that could also cause poor well performance, and you could probably feel that it may be as a result of the, the skin. So before you get into the conclusion that it is the skin, you must have eliminated all of these parameters. You must have eliminated all of these. So they are now asking a question. Have you eliminated these possible sources as a cause of the problem? You will take yes. Then we have the acceptable improvement. For sandstone, typically you can expect up to 90% reduction in skin from a metric stimulation. This may or may not be acceptable based on the payout you expect. Is a 90% improvement in the skin acceptable? So they are asking you how you want to improve. Some company may not want to improve the skin that much because it will also come with some kind of consequences, because probably you have to start adjusting. If you are having very high production, you have to start adjusting maybe the wellhead pressure, start adjusting one or two things around the wellhead in order to accommodate that high flow rate. So they are asking us if we accept the 90% improvement. If we accept the 90% improvement, then we take continue. Then this is now the conclusion of all of this. The well is an acceptable candidate for metric stimulation. Proceed to the formation damage advisor. So from all the input that we have done, the system is now telling us that we can apply metrics as dicing in that particular system. We can apply metrics as dicing. So we have now finished with the first part from our workflow. If I take the general input, that's our workflow. The first is the candidate selection advisor. The second is formation damage advisor. So I can always change from up here. I'm already done with this. Then I now go to the next one, formation damage advisor. I take the formation damage. They now are now asking other set of questions that you have to answer. Then from here now, the system will be able to probably maybe give you some possible causes of the skin. What may have caused the skin? Is it due to perforation? Is it due to paraffin deposition? Is it due to scale deposition? And so on. So they may now give you, is it due to fine migration? So due to whatever you put here, they'll be able to tell you exactly what type of system you are dealing with. So what I will do here is I will just open what I simulated the other day so that we just work with the data. No. All right. So at the beginning, candidate advisor is the same thing, oil reservoir sandstone. All right. This is what we have. Do some adjustment. We have 150 there. Our net pay, we just put, let me use the values that we used. Bottom hole flowing pressure 900. Okay, I've already done this the simulation. Oh, what am I putting there? 1,500, 150. All right, so that's exactly what we had. So we move further. Yes, yes. All right, so that was where we are. So the next now is formation damage advisor. So they are now asking us what type of production system, what type of production are we dealing with? Is it a new well? Is it continuous operation that we have? Is it continuous operation with steam? Is it workover or stimulation? So we are just going to choose our continuous operation because the well has been undergoing continuous operation before you want to apply acid stimulation. So we'll go to the next. All right, so what type of well? Is it a producer or an injector? But yeah, it's a producer. So we have our oil producer there. Then the next, why do you think the well is damaged? We have unexpected gradual rate loss, unexpected sudden rate loss. So this one is probably, it could be gradual, because if it is sudden, it will, because formation damage is a gradual process. So generally it's going to take some kind of a gradual loss in our rate. So if I take the next, all right. So here now you have to input the mineralogy. You have to input the mineralogy of that particular reservoir, because the mineralogy will give us a clue about what type of acid we are supposed to use. Some acid will not work in a particular milieu while it will work in others. If I have a system that has no clay, then there is no way I should be thinking of fine migration, even though we could have silt, but most of the time fine migration is as a result of clay, particularly semactites. So I have to input the mineralogy of our formation. We have there, you don't need to input the one of quartz. So you see quartz is blue in color, you don't need to input. Once you are inputting these other parameters, it's automatically adjusting because all of it should be 100%. Because if you open your own, you will just see only 100% here. As you're changing these values, this value here will be changing. So we have calcite there, we have potassium fluorspars, we have sodium fluorspars, we have the kaolinite, we have segmatite, then we have chloride also. So these are the various things that make up the formation. So I'm going to, anyway, once you watch the video, you'll be able to pick out this property there. If you're doing it as you're doing it, you could just quickly pick out the values and you put. If not, you just follow the video and you pick the values. So if I go to next, they're now asking other questions. Why do you think the well is damaged? Check any and all observations that apply. Why do you think the well is damaged? There may be some kind of an additional thing that you think. For example, apart from because I've talked about the segmatite, which will definitely produce our fine migration, but there may also be some other things that you may have observed. What are those other things? Have you seen any paraffins or alpha-thins in the oil? Where did you observe it? You may have paraffins observed in wells in the past, paraffin or alpha-tin observed in the surface equipment, paraffin or alpha-tin observed in tubing. So wherever you observe the paraffin or alpha-tin may give you a clue of what type of damage you have. But in this case, let's assume that we have not seen any of these parameters. So we'll just go next. Have you performed a pump-in test on the well? So we are just going to take no. They are giving us a warning here. A pump-in test can help identify damage due to fine migration, water blocking, or clay swelling. So it's just some kind of a test that is done in order to determine what type of damage we may have within the particular reservoir. So in this case, we have not done the pump test, so we'll just leave it simple for now. So we go to next. They are also asking production equipment observation. What have you observed anything in the production equipment, like some kind of a scale, or have you seen any reduction in the tubing inner diameter? Is there any kind of observation that have been done, that have been seen on that particular parameter? So we'll just assume that we have not seen anything as concerned that. Then check all statements applicable to your well. The well showed rapid decline. The well was produced at high drawdown rates. So what this simply tells us is that the well may have been producing at a very high drawdown rate before this damage occurred, before the rate just gradually declined. If the well is producing at a high drawdown rate, then it's possible for us to have some fine migrations. Because if that well is not producing at high drawdown rate, there will hardly be fine migration. So these are various things that will come in to tell us to enhance the identification of the type of damage that we may have in our system. They say a well showed rapid decline, so you could also determine each of these. So let's just click two of these and see what we have. All right. So they will now tell us that the advisor has found that the following are possible damage mechanisms. So it has identified that we may have fine migration. Remember, it is identifying fine migration because that is what we have as of now. That's what it has as a result of the StimCADE that it has, and as a result of us indicating that the well was producing at a high drawdown rate. If you have indicated some kind of scale formation here, you also indicate that. If you have indicated some kind of paraffins or alpha things here, it will also indicate that. But for now, it has identified only fine migration. So what we will do now is you can go to explain. It will explain to you exactly what the fine migration is. Fine migration is identified as a damage mechanism because this is a producing well. So they are giving you a reason why they have identified the fine migration as a possible cause of that formation damage. We could get it there. So if we go back. So for us to select this, you just click on this because you will not see this here, selected damage. You click on this, then you can click select. When you click select, you have it there. Because there are some cases that may give us some possible damages and probably you may have eliminated that one way or the other and you don't want to analyze that and you don't want to put that in your simulation because you may have done some kind of an analysis to show that there is no way that could be a cause. This is just an advice, so it's not like it is absolutely 100% correct. It is working on the data that you have, and then you have to now accept what it is telling you at the end of the day, or you reject what it's telling you at the end of the day. So we are through now with the formation damage advisor. The next thing now is a fluid selection advisor. So we have to look at the fluid selection. What type of fluid do we expect? What type of acid are we going to use and at what concentration do we expect to have it? So our primary damage here is the fine migration. You may also include some secondary damage if you wish. You could also toggle it down, and probably if you have identified some minor indications of something, maybe not fully, but just minor, you could now select some of these. It could be scale, calcium carbonate, what type of scale. It could be paraffin, it could be clay swelling. We could include some of it, which is just a secondary damage, not the primary damage. It's just a secondary damage. So we'll go to next. We also have to input our mineralogy because the acid also will depend on the type of minerals that we have within the reservoir, because some acids will not work in particular mineralogy. So we have to always identify them because we have to ensure that the acid has to treat the damage rather than causing further problem. Because if the acid goes and dissolve the rock, at the end of the day, we may have a problem there that has been created, a bigger problem that we have to solve. So the mineralogy also will go a long way to determine what type of acid we are going to use. So this is our mineralogy that we have already seen. We take next. Okay, make selections that best describe how your well is completed. We have orientation, horizontal, height deviated, straight or moderated deviated. So we'll take that. Then what type of completion? Is it open hole? Is it a case hole? So we'll take our case hole. We have some gravel packing and so on. So we are going to take our case hole. Then the next now is the reservoir information. We have our reservoir permeability, the true vertical depth of the reservoir from the top, the true vertical depth of the reservoir from the surface to where the reservoir is. So we could just say, from what I have here, I think it's 9,000 let's say 9,600. 9,600, that's our reservoir pressure, and that's our bottom hole temperature. Bottom hole temperature, yes, let's leave it at 160. All right, we take next. Our producer is an oil producer, so we take next. All right, that's our perforation interval. Our perforation interval could be, let's say, I think I'll adjust this. Let's go in front. I have a data for that. I'll look at that and adjust that. All right, so we continue. Is nitrogen required for treatment done on this well? So we are going to say no, nitrogen is not required because there are some of them that will need nitrogen. Is the fine problem severe? We are going to take yes. So we take, so they now give us a clue of what the acid is. But what you have to note is that most of the time, most companies may not have some of these acids exactly as it is defined here like this, but this will give us a clue of what property of acid we need. Because if they are talking of hydrochloric acid 7.5%, then even if you don't have that, you should have an idea of what you can use in the place of hydrochloric acid that has similar property based on what you have at hand. So when they have given this, it doesn't necessarily mean that they have to use it exactly as it is. They are just giving you an advice of the various acid that you need and the various stages. At the various stages that we have our pre-flush, we have the main fluid, overflush, we have the deviated particulate, and then we have overflush again. So they are giving us the various acids that we need in these stages. So I have not really talked more about this because under hydraulic fracturing, I actually mentioned things that relate to these stages. All right. So if you accept this, we are going to take transfer to acid placement. Transfer to acid placement. So we are going to click this. Once you click that, if the acid is going to be transferred to acid placement. All right, we now go now to our StimCADE again, and we take the next one, which is our pumping schedule generator. So we take our pumping schedule. So we have this. These are the acids that we have in our first step. We could always open this up. These are the acids that we have, and we are accepting that we can use the acid. Then at what rate do you want to use these acids? That one also has to be defined. At what rate do you intend to use these acids? So we could say our rate here, let's say we have 2. Let's just vary it, but there has to be well-defined rate. 2, 4, 5. Then our liquid volume, the volume of this that is required, the volume of this, you have to indicate the volume that you need, the volume that you want to pump in. So we have, let's say 50, 40. All right, so that's exactly what we have for our schedule. This is our schedule, which is well defined. The next now is for us to go now to the acid placement to see, run the simulation and see what the result will be at the end of the day. So we'll go to our acid placement. All right, so our schedule comes up, but for the acid placement, there are a lot of things here that you have to input them before the simulation can go. If you don't input these parameters, you will not see anything at the end of the day. So the first one here, we click there, that's our, is talking about the configuration of the well. So we have well completion, we have that. All right, I'll go to this before I'll come back to this. So the first is our whole survey. So the whole survey ends, the entire drill hole will end at 11,000 feet. Entire drill hole will end at 11,000 feet. If the well is deviated, you can include all of these parameters for deviated well. You can include all of these. Then for tabular, we have our tubing. Then we have our casing. Our tubing will end at 8,000. Our tubing will end at 8,000 feet. Then we have our inner diameter of the tubing, and then we have the outer diameter and the inner diameter. Then we have the width of the tubing. If you know the collapse pressure, you can put that. If you know the burst pressure, you can put that, because all of this pressure will go a long way. But since we don't have these parameters, it's okay also like that. For casing, the casing will run right down to about 11,000 feet. That's the depth of the well. Run to about 11,000 feet. That's the outer diameter, inner diameter, and that is our width. So we come back to completion now, and this gives us, this is our completion. That's how it shows. So where do you want to pass the treatment fluid? That's where we have here. We have through the tubing. It could be through the tubing. It could be tubing annulus. Once you put tubing annulus, you realize that this part is blocked. This is where the fluid is going to flow. So we can put tubing annulus. So once you put tubing annulus now, it is giving you the placement volume, the volume of the fluid that is required to fill this particular area, to fill this particular volume of the drill hole. But we are going to take our tubing. We are going to take our tubing. So that's the volume that is required. So we have our perforation. So we click on that perforation. All right, we have all of those parameters. We go now to the next. We click on the next. We have our well, the drainage radius of the reservoir height. The reservoir height, I think what we used there was 45 feet. What's the well ball inner diameter? What is the temperature of the bottom hole, the reservoir pressure, what type of fluid we have. Then our PVT property of the fluid. What is the viscosity of the fluid? What is the compressibility, and what is the liquid gravity? What's the liquid gravity? You can come to our PVT worksheet here to see exactly what you can do there. Our PVT worksheet here, we can now indicate the saturation. You have water property, gas property, and oil property. We don't have any gas. That's why our saturation here is 0. So that we have 25% water saturation and 75% of oil. We have our initial gas oil ratio. We have our bubble point. We have our API gravity. We have our API, our oil in API gravity. Then what type of correlations do we want to use? We have already discussed a lot about this PVT correlation. So once you have inputted all of these parameters and you come to calculate, it will automatically calculate these properties here. You automatically calculate this property. So the next one now, all right, so we may have different zones that you want to treat. So we are going to just make it easy. We have just a single zone. So that's our zone 1 there. So for the zone, where does it start and where does it stop? So it starts at this level. The zone that we want to treat starts at 9,600, and let's say ends at 9,645. Then our perforation will start at 9,600. Then it ends at 9,635. Let's say 9,635. All right. So this is the thickness of our reservoir, and this is the thickness of our perforation. What is the reservoir permeability? Horizontal permeability, that's what it gives you. You automatically calculate the permeability thickness by taking the permeability times the thickness, which is that 45. We have our porosity. What's the porosity? We have our fracture gradient. We need to know the fracture gradient because we need to be sure that whatever acid we are sending in should not fracture the formation, should not fracture that particular formation. So we have to put this, let's just say 1.7 and see what we have. We have our permeability ratio. That is the permeability, the horizontal to vertical permeability. We have our zone pressure, which is 1,500. So that's for the property. We go now to lithology. We have to still input this lithology. we have to still input this lithology. Now you go to damage and make sure that you define the damage as fine migration. Define the damage here as fine migration. After you must have input this lithology. If we have done that, we go now to the next. The next is just telling us that based on the parameters that you have inputted, the system will calculate all of this. I think we did most of this explanation under Prosper. It has calculated our skin due to deviation. It has calculated our skin due to perforation. Then we need now to input our damaged skin, which we already calculated in the first step, and it was 8. So it will now give us our total skin. So based on what we have, the system is doing this calculation for us. If you don't understand this exactly, you can go back to our Prosper. We explain all of these skin damages there. All right, so that's that. If you want to add any other acid, you can add that. All right, so that's our schedule. So what we are going to do now is to execute the simulation. So when we do that, we click here and it's going to do the simulation. So what this is telling us is that simulation exceeded fracture pressure during treatment on stage 4. So at stage 4, this is our 4th stage. At 4th stage, the pressure was so high in such a way that it exceeded our fracture pressure. And this tells us that if we insist on simulating right up to that stage, it will not only be acid stimulation, but we could also have some acid fracking. Acid fracking is a situation where you are pumping the acid not only to treat, but you also want to create some artificial fracture within the reservoir. So this is telling us that at stage 4, we may have acid fracking. So we may shift that and we see all of these acid.
Hello? Hello?
Yes?
Yes.
Please, your mic is disturbing, Brian. Okay, so from there now we can see, voila, we can see this is the main part. This is the main thing in this acid treatment. You see the variation of the skin as a result of the pumping volume. That's the variation of the skin to show us that as your before, at the end of the first 50 barons of fluid that you have pumped into the system, the skin has reduced to about 7. By the time you get to the last pumping, we are having a skin of about 2. We are having a skin of about, yes, close to 1, which shows that at the end of this treatment, we should have a skin that has reduced from about 8 to about 1 point something, which is actually a good change, a drastic change. During acid treatment, it is not a must that you must remove everything. It may be impossible attempts to remove everything. That's the reason why in most cases, you may not have a negative skin like in hydraulic fracturing. Because in hydraulic fracturing, we are sure that once we have created the fracture and we have used our propan to block the pores, the fractures from closing up, we should be able to have high drawdown or high production. And that should be able to give us a negative skin. But since in acid treatment, we are struggling to remove these contaminants within the reservoir, it may not be 100% visible for us to actually remove everything within that particular reservoir. So we may not expect to have a negative skin. I'm not saying that it is impossible. It depends on what your simulation will give you at the end of the day. I'm not saying that it's impossible. So if this result now is satisfactory, then the company now might go ahead now and apply and now execute the job and now go now and do the job execution at the field. So from there now, so what we have here now is acid placement pressure. This is our pressure, rate, and time. So we have here, this is our pressure, this is our rate, and then this is our time. What we have is the variation of pressure as we are going and all of that. So we realize that the pressure becomes so great within this minute, and then becomes higher within this minute and this minute. So that's exactly what we have here. We can close this up also. Then here now is also our volume, the variation in our volume. At each level, what is the variation in the rate of pumping and the volume, the rate of pumping against the volume of fluid that is being pumped. So you could also come here. So this is a summary of what we have. This is a summary of what we have. The quantity of acid that you need for zone 1, what quantity of acid do I need for this first? The quantity of HCl that I need is 59.96 gallon that you need. Then they are telling us here if we have any fracking. So they are telling us that at stage 4 and stage 5, we have not only acid treatment, but we have also acid fracking also at this particular level. So it is also giving us the change in the skin at each stage. When you pump this, that is how it reduces. And then the final skin now is around 0.69. So this is our final value of the skin at the last level of pumping. At the last level of pumping. So you could also come here to get those plots. So once I click here on graphic, I could look at radial penetration. I click on this radial penetration. I click on select. So I have it there and I generate. And then I now see exactly this is our key here. You can look at your key to see exactly what you have. These are the various acids that we have within the particular formation. You can see the various acids, the area, the drainage area of that reservoir that is occupied by the various acids. You can see all of it there. You can see all of it there. We can also look at so many things. You can also look at, here we have, let me remove this. Okay, friction, let's see. We could also look at friction. All right, this one cannot actually, it can plot only for a carbonate reservoir. This can plot, oh, I've closed the system has crashed. All right, so anyway, that's what we have. That's exactly what we have for our simulation. I've shown the various properties. I've shown the various parameters that you can have at the end of your simulation. Hold on a bit. All right, so I have shown all of these parameters. We go to acid placement. Let me reopen back the project. Open back the project there. No. All right, so that's what we have. So I said there are so many things that you can go to graphic and plot them. The acid weight with time, you can also look at that. Acid weight with time, the plot of. Okay, this one is generated, it's clear there, is generated only for a carbonate reservoir. That one is generated for a carbonate reservoir. So what we are working here is our sandstone reservoir. There are some plots that can only be generated for a carbonate reservoir. So once you look at all of this, then once you're satisfied with the result, you can now execute the job. Because if I look at my general input, if you look at this, after you're done with the acid placement, you can now look at your report and graphic, which we have done. Then you can now go now to job execution. The job execution now is the actual field activity. That means they have to start carrying the acid, they have to build the equipment, and then they have to start pumping exactly based on the schedule that we have done our simulation on and the reservoir properties. So if you have any question, you ask. If there's no question, then I think this will lead us to the end of our internship. All right, so what I wanted to say is those of you who are attending this internship as your main internship, not just because I know all of you have internship already. Those of you who are attending this as your main internship, you indicate in the group and I'll give you a project that you're going to work on. A project that you have to submit at least it might take you at most 1 month to submit. I will draw a project that we can cut across 2 or 3 of the softwares. Then you have to do it and then you submit it. Only those of you who are using this as your main internship, you indicate and I'll give you an internship project that you have to carry out. If you don't carry out that internship project, then there is no way we have to sign your internship form. If you have to sign your internship form, that project must be carried out well. So if you are using this as your main internship, then you just write your name in the group and I'll design a project for you that you have to take at least a month to submit. So if you have any question, you can ask. If there's no question, we'll always be communicating in the group when there's any problem. So once you have attended this internship, it goes a long way also to help you in so many aspects. If you want to write a project on any software that we have done in the nearest future, and then you're having difficulties, I can always take you through the software. If you're having any difficulties on what we have done, not outside what we have done. Because if it is outside what we have done, that's a different arrangement. If you want to write a project on any of these software that we have used, and then you face difficulties, you can always ask, and then I will take you through. There are some of this software that we can go deeper. If you have to write a project on any of them, we could actually go a little bit more deeper. There are some of them that we did not go that deep because of time. But at least we have done the main thing that anyone who sits on it and follow exactly what we have done should be able to go a little bit further, not just ending where we have ended. Because the most important thing in any software is for you to understand the interface, understand how you can move through the interface. That's why most of the time I have to take time to explain the interface so that you have to know how to move through the interface. Once you have known how to move through the interface, it's always easy for you to do anything you want to do. So if there's any question, you can ask. If there's no question, then I hope it was a successful internship. So as I've said, those who want to, who are taking this as their main internship, you just send me your name in the group and I'll design a project. You give me 1 week and I'll design a project for you. By the end of next week, I'll send you the project for those who will indicate.
Okay, thank you, sir. I want to thank you for the time. And then my question would be, are those videos, will they still be available for us in the near future, or
The
access?
videos are there for lifetime. Lifetime access. You have lifetime access. The videos are there. It's not going anywhere. Even after 20 years, you will still be able to access it. So long as
Okay,
you're using
thank you,
the
sir.
same email, so long as you're using the same email, you should be able to access it. Is that clear enough?
Yes, sir, it is very clear. Thank you very much.
Okay.
Hello, sir.
Yeah.
Thank you for the internship. I really appreciate that. But when you talk about the main internship, what